Good morning and welcome to Cloud Week, Kubernetes edition. I hope you are enjoying the event so far and are ready for another exciting talk. Joining us are Alex Yochev and Adrian Calinescu from Microsoft. As engineers and tech evangelists, they cooperate daily with many different companies, sharing their knowledge about Microsoft's latest solution. Today, they will be giving us a closer look on architecting and running Kubernetes on Azure. Before we start, I wanted to let you know that this session is being recorded and will be made available to all registered participants after the event. If you have any questions during the presentation, please use the dedicated chat section in the dedicated question section in the chat. We will have a Q&A session at the end of the presentation, during which we will address all of them. And now, without further ado, I give the stage to Alex and Adrian. Take us away.
Thanks, and hello everyone. I hope that you're having great sessions. So let me share my screen and really kind of a deep dive into it. So just let me know if you can see my screen. It should be fine. And my name is Alex. I'm a cloud solution architect here at Microsoft. I come from pretty much heavily development background. Lately, I'm doing things predominantly in the DevOps area, and today I'll be presenting with Adrian as well. In this session, we are not going to talk about the Kubernetes basics, but we'll try to show you as much demos as we can. And without further ado, let me kind of go into it right away. First of all, a couple of basic things that I need to mention. So on Azure, what we are offering is a managed Kubernetes service. And basically, this means that we are taking care about the cluster hosting, upgrade, patching, scaling, as well as we are providing you with all the necessary tools for monitoring and logging. And if you want to have like a better visualization of what this means, if you're having like the self-managed Kubernetes, you'll be managing your master node. Basically, we are taking care of this, and all you need to do is basically take care of your node pools, the pods, and the deployments. And of course, the management comes at no charge. Of course, there's a lot more things that we offer on top of it. So this would be the RBAC access control with the Azure Active Directory, integration with Key Vault for all your secrets. It would be compliance, certifications, integration with our VNet, and a lot of other stuff. Some of the things that we'll mention is the Azure Container Instance. We'll be talking a little bit more about it later. My colleague actually has a pretty great demo about it as well. Of course, if you are not happy with what we offer, but you still want to use the Azure infrastructure, there's a way to kind of run and manage your own Kubernetes. We try to make this as smooth as possible. So there's an open source project that's called the AKS engine. Basically, that's also what we are using. And this could give you really a kickstart into deploying your own Kubernetes with your own customizations if you are brave enough to do that as well. Two things that I need to mention that for me kind of a stand up from what we offer. First of all, it's the so-called virtual nodes. So as I mentioned, we have the Azure Kubernetes instance. Basically, that's I would say, a serverless containers, if you wish. What you need to do is just book some processors, book some memory, and kind of deploy a container on top of it. And you only pay for the time during this which is running. Of course, you can connect this with your Kubernetes or manage Kubernetes along with your pods. And this is great for any time that you need some burst capacity, but you don't want to allocate new nodes. So that's one of the great architectures, and I think one of the great things that we offer. The other thing is really the open source broker for Azure. You can decide to run your services like, I don't know, maybe database, cache service, etc. in your Kubernetes nodes. But with the open service broker, basically you can connect your Kubernetes directly to the managed services that we are offering. And from this, basically you are benefiting from the SLA backup services that we offer there. And I think that that's a great solution if you want to kind of simplify some of your deployments. And the last thing that I just want to mention here is basically the monitoring tools that we are offering out of the box. Because you're running on top of the Azure infrastructure, we provide you with the necessary tools to monitor and see what's going on with the nodes, with the VMs, but also with the, I would say, with the cluster and the deployment in general. Now, if you've been working with Kubernetes for a while, most probably you will notice that Kubernetes on its own is really not enough. You need to have like an entire ecosystem of tools in order to run and operate this on a day-to-day basis as well. So essentially you need tools, and we do provide a lot of tools out there that are part of the, I would say, the AKS infrastructure. Of course, we do contribute back to the community. So most probably you're familiar with Helm, Drop, Brigade. My colleague will do a demo on the Dapper as well. I've mentioned the virtual kubelet, which is basically the extension with Azure Container Instances. So all those things are available. But on top of this, of course, when you are on Azure, you can kind of benefit from pretty much all the open source tools that are available. Now, most probably you see where I'm going with this. Pretty fast when you are doing like Kubernetes, tools kind of a pile up, so you need some process to kind of manage this all. So of course I'm talking about putting some sort of a DevOps process in place. So essentially, if I have to summarize it, Kubernetes and DevOps kind of run better together. In its very essence, when you're doing like an end-to-end deployment with Kubernetes, what you'll usually have, you'll have some source control place where you have your Docker images or your application. You need to have some sort of a CI/CD pipeline to build your containers. And then one of the best practices is actually to push the already available Docker images into a container registry. Of course, this could be the Azure Container Registry. There are a number of benefits of using a container registry in place. And when you're deploying, essentially, you will be deploying only from the container registry itself, rather than directly to the Kubernetes clusters. At the end of it, of course, you need some tools to monitor what happened, whether the deployment was successful, and how it's behaving. So in my opinion, this would be the very, very baseline of a workflow that you'll need to have. As I said, using a container registry is kind of, I would say, a good practice. If you're using the Azure Container Registry, basically you can kind of benefit from the private registry itself, but also on top of it, you can run things like security, vulnerability scanning. So we do have some integration with Aqua and Twistlock. So these kind of come out of the box. So I kind of prepared two demos for you today. One of them is kind of to show you how you can accelerate your deployment. And what we are going to do is we are going to use a, I would say, vanilla GitHub repo, where I have a very, very simple application. And from there, what we'll do is kind of take the container that's available and deploy it to an AKS cluster using an Azure Container Registry. And we're going to do this through like two pipelines. One of the pipelines will be using the GitHub Actions with all the actions that are listed there. And the other would be using the Azure pipelines and kind of showing you what are the difference and what's available there as well. And once we deploy, of course, we'll take a look at it from the perspective of the Azure Monitor, what's available. So for today, I kind of prepared this simple deployment. As you can see here in my, I would say, console, I have like two things being prepared. One is the AKS cluster, and the other is the Azure Container Registry that's there as well. So just to quickly show you, that's the AKS cluster that you're kind of having on Azure. Out of the box, basically, you can see your node tools. So what's available there? As you can see, I just have only one node. It's a Linux one. It's running on a standard VM. Of course, I have all the options to kind of upgrade and go directly into monitoring and see what's going on with my containers, deployment. So this kind of comes out of the box. The other thing is the Azure Container Registry itself. As you can see, that's how it looks. This is the two kind of parts where I can integrate with security. Currently in the repos, there is nothing has been deployed there. Actually, that's part of the test that I did. So I actually have two images there. I forgot to clean them up. And this is, let's say, a nice view of what happens behind the scenes. So this is my AKS cluster, and these are the actual physical resources that has been used. So for example, for the node pools, I have the virtual machine scale set that's being used in order to kind of run the VMs. That's the load balancer that serves as an ingress controller. That's the public IP. So, I mean, when I'm talking that you can deploy this on your own on top of Azure, you'll get something like this. Of course, this is managed by us so far. And for the deployment today, just to show you, I used a very, very simple script that kind of create and provisioned all those things for me. And also, here is my repo from GitHub with the very, very simple application. You'll notice it's a Node.js application that basically kind of says hello world through a web interface. And from what you'll notice, that's the Docker file that creates the image. And if I go back to the repo itself, there's no deployment descriptors. There's basically nothing. It's just the good old repo that's available there. So if I want to take this repo and kind of deploy it directly to the AKS cluster, one of the things that I can do is go to the deployment center here, directly from the console, and say, add a new project. And from here, I can choose where my source code is. So let's go to GitHub. I will authenticate directly to my GitHub. So I'm kind of looking at all my repos here. That's the repo that I just cloned. I will be using the master branch that's available here. So currently what happened is that the deployment center kind of scanned my repo and found a Docker file that could be used to make a deployment. So that's the Docker file that I want to use. So let me click next. And from this point forward, it's asking me, do you want to use an Azure Container Registry to push the images? So that's the container registry that I have. I'll use an existing one, and let me click done. And with all these, currently, there are some kind of a communication happening between the GitHub and the deployment center. So if I go back to the GitHub part, there should be some change, right? As you can see, the first thing that came up is those manifests. They weren't there before. So this is the deployment descriptor that was created for me by the deployment center. And that's the service descriptor that was created for me as well directly. And also, I have a workflow or a pipeline now. So if I check it, these are all the necessary kind of steps that are required to build the Docker image, push it to Azure Container Registry, and once it's there, kind of deploy it to the AKS cluster itself. So some of the things that happened behind the scenes was kind of creating all those descriptors, but if I go to the secrets, you'll see that now, about 1 minute ago, I got the password and the username for the Azure Container Registry, as well as the necessary credentials for the Kubernetes clusters that I have selected in order to make the deployment. And if I go to the actions itself, you'll see that right now, currently we have an in-progress build that kind of completed from what I see. Oh, it's still in progress. And this is the deployment kind of going on right now. Now, while we are waiting for this to complete, let me kind of quickly jump back and see what else we can do with the Azure pipelines itself. So for the Azure pipelines, I just wanted to show you a different experience. If you're using Azure pipelines, basically that's an empty project. I'll say create a pipeline. And for example, again, I'll be using GitHub. And from the GitHub, this is the list of all my repos. I selected the repo that I wanted to use. And out of the box, as you can see, there are a number of pre-built templates for pipelines. I'll use the deploy to Kubernetes service. Here at the Azure pipelines, I need to check and use a subscriptions. I'm really, really hoping for a fast internet today, so I don't have to wait that much time. It's taking some time, so let me quickly jump back here and see. Okay, here my build actually completed for about 2 minutes. So let's see. Let's check the subscriptions here. Say continue. And because we have a completed deployment, let me go back to the AKS cluster that I have. And as you can see, I have a new project. It has been deployed. And if I go back to the console and do something like kubectl get namespaces, you'll quickly notice that I have a new namespace. So for example, this workflow actually deployed to a new namespace that I can actually use and do some tests there. So if I do kubectl get pods for this specific namespace, I should get the running pods that are available here. And just let me show you something like even cooler here. If I do refresh on the infrastructure part, because I have a new node and a new public IP, actually a new node namespace, there's a new public IP. So that's the public IP that I have in. If I kind of hit it, I hope that I got the correct one. I get the hello world. So that's the deployment that we just made. So let's quickly jump back to the Azure DevOps pipeline. So here's the cluster that I'm selecting. I will say that I'll use an existing namespace, and this time I'll deploy to the default. I'll use the container registry again. So let me name this like app nodes container. And there's a very good feature, enable review for the app flow for pull requests. So this means that, for example, if I enable this, if we are doing like pull request in the Git repo, first we'll do a check into a new, let's say, namespace. Once that's been successfully deployed, then we'll be able to close the pull request, and this will be deployed to the default namespace here. So let's click on validate and create. And this is kind of a generating the YAML file that will do our build for us. Now, there's something kind of a very useful here. So that's the pipeline that we have, and I'll just save it and run it. I'll commit directly to the master branch rather than creating a new branch, just to kind of speed up the things. And once I kickstart this, the pipeline itself should start, and we'll be able to see the progress on its own. And you have this really nice user interface that's kind of a saying, currently we are at the build stage and we are waiting for a build agent to become available for us so we can start the build itself. And as you can see, there are two additional stages here. One is the deploy and pull request deploy. And you'll see if we were doing a pull request before a deploy, first, this would be completed. Once we close the pull request, the deploy itself will be triggered. But while this kind of a build is running, I wanted to show you something really, really cool here. When we created this kind of a pipeline, it created what we call an environment here. So the environment kind of gives you an overview of the namespace where you are deploying. In this case, this is the default namespace. So here, basically, you can see the workloads and the services that are available. Right now, we only have one service, which is the cluster IP. Of course, if you want, you can add new environments. And because we have an environment in this Kubernetes cluster, which is the namespace that we deployed it to through GitHub, so let's just kind of select the right subscription and kind of use the correct cluster. And this was the namespace where we deployed it. So if I create this environment as well, you can check what's available there. You can see the replica set. You can see the pods that are running right now. And also, if you go to the services part, you can see the service that was available, the public IP. And of course, if you're looking at the pods themselves, you can see a live logs that are coming. And this is something that you get directly in your CI/CD pipeline. And for me, this is very, very useful as a developer or as a guy, an ops guy that's deploying, because I can get this fast feedback rather than going to the command line, running all the commands, etc. So you can have a very, very quick way to check if this was successful and what's going on. So kind of going back to the pipeline itself, as you can see, it kind of started, it's running. I can also see which is the specific commit that was used, which is the branch itself and the branch history. So a lot of details, a lot of useful info that you have. If you are using the Azure repo rather than GitHub, you will not only see the commit history, but also work items that you have attached. And of course, any build artifacts that are available there. As you can see, the build stage completed. The deployment is kind of currently in progress. So this is kind of running. So while the deployment is running, let me quickly go back to the Azure Container Registry. If I do a refresh, if you remember, I kind of named my repo differently, the app node container. So with the build being completed, that's the image that I get. So that's the information that's available there. And this is where the data is actually being pulled from. So while this is running, let me kind of go back to the environment itself. Currently, as you can see, you have a complete log of what's going on step by step. You can also check the time for each of the components that's been running and kind of get information. And that's very useful when you're kind of doing debugging on the deployment itself. If something went wrong, if something's kind of not running very well, it's on its own. So these are the build details that are available there. So these are the complete logs. So while kind of this is still deploying, let me quickly jump back here and go to the Azure monitor itself. So if you have the monitoring enabled, and let me show this here, as I told you, that's the script that I used for kind of deploying all this infrastructure. As you can see, as part of the Azure AKS create, I used a Notion enable add-ons. So this is the monitoring part. So by doing this and by enabling the monitoring, I actually gave access to having these monitoring capabilities where I can see all my nodes, the health of my nodes, which are the containers that are running there. So as you can see, these are the containers that has been deployed, controllers, and all those details. And of course, even from here, you can kind of select the container and go and do things like view live data, so get like the live debugging information. And of course, you can monitor all your clusters from here as well, which is very useful. You also get the option for a metrics. So for example, you can kind of decide for a specific kind of a build metrics, different metrics as you wish, and kind of create all those useful dashboards for you as well. Let's go back and see if our deployment has completed. We are still deploying on Kubernetes.
Alex, just a quick mention of your time. Like you are on the 20 minutes mark, so you can you can go on. No worries, but just to know.
Thanks. I'm wrapping it up. So as you guys saw, these are the two ways that you can kind of create a deployment directly from a repo, whether using the GitHub Actions or Azure DevOps pipelines. Basically, you don't really need to kind of deal with deployment descriptors, etc. This is created for you. You get pretty much everything. And of course, on top of this, you get these like really, really nice tools for monitoring what's going on, whether the deployment went well, wrong, what happened, get all the outputs and all those informations as well. And with this, I will kind of leave you in the capable hands of my colleagues, my colleague Adrian, which actually prepared some amazing demos on its own. So Adrian, the floor is yours.
Thank you, Alex. This was amazing on its own. Like just by seeing how quickly you can automate things and also inject like security steps, build steps, check steps, testing steps in your pipeline, and then making sure that the right image ends up on the cluster. That's extremely valuable.
Yeah, and kind of makes your life easier, really.
Absolutely.
Really.
That's why we are here, right? Because otherwise, this whole cloud managed thing wouldn't make sense if it would make things more complex for the actual users. Cool. Let me try to switch to my second monitor here. So it's this one. All right, cool. So what I'm going to talk to you about first here is node pools. So I'm going to open a cluster that I have here. And by the way, yeah, you can put animated GIFs inside the Azure portal because it supports Markdown. So that's a really nice feature. You can go to the cluster itself, and I wanted to show you node pools. So node pools is a way for you to have multiple size nodes inside your Kubernetes cluster. Why do you need this, right? Because you can scale out from 1 or 2 machines to 100 machines, and that's no problem. Well, yeah, but what if you need GPU machines as well? Or what if that special, Black Friday comes in and you need some really beefy machines, but just for like 2 days? You don't need to change your cluster or to deploy a new cluster with that new set of machines because Black Friday is on, right? You can deploy a secondary pool where you can then move your deployments, or you can set up new deployments, and then you can scale that individually. You can scale it on a schedule, and so on, right? It's a completely different compute pool that you are in control of, and you can put something like an ingress controller in between, and you can route through FQDN or like simply URL routing and so on. So I have a CPU pool here in this cluster and a GPU pool, right? And to show you that I can scale these individually, I can just go to scale here for the GPU pool. These are NV6 machines with M60 Teslas, so NVIDIA CUDA GPUs. And you can just go ahead and scale to 100. Of course, my subscription is actually limited because otherwise all architects would be running at max with all their nodes. Okay. There's also autoscaler, which is easily controllable through either the UI or via the CLI commands. Cool. So let me show you how this actually looks, on a diagram. So there's the Kubernetes managed plane here, and then I'm sending the deployment, right? The GPU deployment YAML, and Azure takes that, the Kubernetes master takes my deployment and then starts to schedule it on nodes, right? And it can use taints and tolerations to be able to schedule the right deployment on the right node pool, because this one should always be deployed on GPUs, right? So then I will have here either a label or a toleration for this deployment to say, hey, you know what? If the node pool has a GPU, then you can deploy. You should go on it, right? So the scheduler knows where to assign that workload. What's really, really neat about node pools is that you can have Linux or Windows nodes. So you can have Windows containers on top of Kubernetes on Azure. And then you can also scale to 0. So you can have this GPU pool only, having one or more nodes when you actually need it, not all the time. A system node pool, on the other hand, must have a minimum of 1 node. Well, that's, it's pretty obvious that needs to happen, because if you do, for example, all namespaces, what's going to happen here is some pods need to run all the time, like core DNS, right? If you don't have core DNS, you don't have DNS within the cluster, so that's never a good thing. Okay, let's go back here. Of course, these GPU and CPU pools expose services because your deployments need services, and then you can put an ingress. In my case, I have a cert manager, so it automatically uses Let's Encrypt certificates, and on the fly generates them for the domains that I'm exposing. Okay. What else? What I really wanted to tell you here is the fact that you can have public IPs on these nodes, individual. So each node can have an individual public IP address. There is one scenario where this is extremely important, and that's gaming. Imagine, a console trying to connect to like an ingress and then a service, and this adds latency. In any kind of gaming scenario, 1 millisecond is already too much. So if you can shave off 1 or 2 milliseconds, you're already there. so you can have this. There's a special option. I'm not going to go into detail. There's a special option which you can pass when you create a node pool, and that's -- enable node public IP, and then each node will get its own public IP, thus reducing the latency. But enough about that. Let's go here and say AKS node pool list, right? Let's see the node pools that I have on this cluster. And these are the same that you've seen in the portal. Come on, internet. Okay, cool. So I have an F4 VM that's actually a CPU-only VM, so no GPUs there. And NV6, this one has the GPUs, right? And if I do az get pods, kubectl get pods, yeah, you know, it's a demo, so you have to mess up commands, okay? I have two computer vision models. One is using GPUs, one isn't. This one is going to use GPUs, and this one doesn't know anything about GPUs. It's the same model, but it's compiled a bit differently, right? And then let's see how these are assigned to nodes. So this one works on the GPU node pool. This one works on the CPU node pool, right? And then how we did the scheduling is by going into the YAML file and then saying here, you know what, I want you to only be scheduled on nodes that have this tag here, right? This limit, NVIDIA.com/GPU of 1. So only if you have this, then you can get scheduled. Cool. So without further ado, let's actually now go to the before that. CTL get ingress. Let me show you that there's an ingress behind these two models, machine learning models, so that, you know, the GPU stuff goes to the GPU one and the CPU one goes to the right one. So let's get the ingress and then let's describe it. kubectl describe ingress low lens ingress. Okay. What's going to happen here is the GPU one is going to go to the YOLO-Lens deployment, and the no GPU domain is going to go to the no GPU one, right? And then there's certificates on top of that, which I installed via Cert Manager. Cert. You can see it here, YOLO-Lens TLS. By the way, this is automatically generated by the Cert Manager and the ingress, right? So as soon as I add the ingress, the certificate is automatically generated. And this is not an Azure thing. This is available in Kubernetes. Especially for Azure, we have Azure Key Vault, where you can define commercial certificates, for example, in DigiCert, and then automatically Azure Key Vault can do the management of those certs, like rollover, renew, and so on, with integration with Kubernetes. So that's really nice. Cool. So now let's open both sides. gpu.yololens.snowball.org. Let's put it here, and then let's create a new window, put it here, and go to no GPU, right? And first, let me just make a little bit of cleanup here. All right, so you don't really have to pay attention which one is GPU and CPU because it's going to be very obvious, right? Because of the speed. So the no GPU one, okay, let's just use a random image. So I'm just going to click here, and then let's just use the same random image on the GPU cluster. So, okay, I'm hitting this. Yeah, this is already finished, and this one, you know, took like 6-7 seconds longer than the GPU one. Let's do this one more time with an actual image that we upload. Okay, so let's go here, select an image. Okay, so this is the GPU one, right? So, okay, let's put this one. Cool. So this took like one second, right? Or under 1 second, and then the CPU only cluster. Okay, it's working. It's working. So you can see at scale how this can become extremely important, right? Imagine if you're doing training for something like an autonomous vehicle, right? So you drive around, and then you have a lot of training data, and then you need something to crunch the training data on, and you can then use node pools to do it. Cool. So I've burned through 8 minutes, so I still have some time. That's good. Let's move over to the slides. Okay. So there is also one more very important thing here to mention, and that's spot instances. This can be acquired at a very, very low rate, meaning that you can pay up to 80% less for spot instances than regular virtual machines. And how this works is that we have unused capacity, and that unused capacity basically goes to a bidding process where people say, you know, I can pay from $0.10 of a dollar to $0.50 of a dollar for this node. So, you know, whatever is less. And if that goes above my maximum bid, then just take it away because I don't care. And this is extremely useful for workloads that can tolerate eviction. And, you know, training computer vision models works very well for this. Or, you know, rendering videos, yeah, that may actually work because you can resume. Any kind of workload that you know, running a job like generating PDFs out of a SQL database, that one is great, is a great candidate for spot instances. But of course, like a web server won't really work on spot instances since, you know, a web server needs to be available 24/7. Cool. So let's now go to the next one. Oh, by the way, yeah, I forgot to, because you saw the Scooby-Doo button here, but I didn't mention it. So let's see what's under the Azure Managed Control Plane, right? So let's do the reveal, the Scooby-Doo reveal. So of course we have the, you know, what's inside the Kubernetes master is like the API server, you know, etcd store, the scheduler, the controller, and the cloud controller, which is what makes all of this work on top of Azure, right? We offer. By the way, this whole thing, because we forgot to mention that, which is a very important point. This is free. Like Kubernetes on Azure is not built unless you need a strict SLA. So a strict SLA comes with an attached bill. However, if you can tolerate the SLA of all the underlying infrastructure, then you can get the management nodes completely for free. And this is very different from other cloud providers where you actually have to pay for the management plane. You only pay for the actual compute, which means the node pools, the ACI instances, the spot instances, and so on. So only for the compute you use, not for the management plane, which I think is definitely worth mentioning. Let's quickly switch to virtual kubelet, which is another way to have more compute, or actually to scale easier and faster in Azure Kubernetes service. And how this works is you have the control plane, and then inside the cluster, there is a virtual kubelet installation, right? And this is a project that is it's an open source project, and makes it available for different providers to plug into the virtual kubelet and run nodes that are outside Azure or outside the cluster, right? They can be inside Azure, they can be in a different cloud, they can either be, or they can even be on premise, right? If you have the right provider. By the way, we have a project for that called Azure Arc. So if you're interested in managing your Kubernetes clusters that are not on Azure but are on different data centers, and to bring it all on Azure in terms of management, Azure Arc is the project that can do that. So going back, there's a virtual kubelet. The virtual kubelet calls into the Azure Container Instances provider, and that's going to the Azure Container Instances service, and that's going to then provision virtual nodes inside your subscription. So these are not VMs. These are simply containers that are hosted somewhere in Azure, and they are dropped inside your virtual network with a private IP. So it's really nice, right? Because they're not nodes, and they can scale really, really fast. And that's, I think, what's a huge benefit here. But how fast? Well, let's take a look, right? So let's go to, right now these are only supported for Linux. So Windows support is coming. Windows support is actually only lacking on the virtual network capability. So that's missing. So that's why it's not possible yet. But if you need Windows support right now, just switch over to node pools, and node pools can have Windows workers as well. They support volumes, they support storage. You can attach storage to them, and then they support virtual networks. You can have secrets, of course, from Kubernetes exposed to these virtual nodes as well. So they function exactly like a regular node. Switching back here, let's do kubectl config use context, and then let's switch to a different cluster that has the ACI connector installed. Sparks joy. Okay, cool. So let's make sure that we are in the right context. Yes, we are. If I do kubectl get nodes, you'll see here that I have virtual node ACI Linux connector here, which is the gateway to Azure container instances, right? So if we're looking here, this is the virtual kubelet, right, with the provider. And let's go and look at deployment. So kubectl get pods here, and we have here. Let me see here. This is. Wait, I think this is the wrong cluster. Just quickly. kubectl get pods. Oh yeah, sorry, it's not a. Okay, so I don't have the pod because the deployment is currently scaled at 0. So yeah, I got a bit scared there that what's going on, right? So if we look at deployment instead, we're going to see that we have a deployment that's called Gophers on Azure, and this deployment is actually scheduled to only run on virtual kubelets. And this again happens with like a little bit of a label that you put in, and then you say, if this node is a virtual kubelet, then we can run that. And we can actually go here and check. kubectl describe deployment Gophers on Azure. So this one, this one is, it has this label, and then it uses this image in my Docker repository and image repository, and then exposes port 80. Cool. So now, let's scale this out, and then let's see where it gets scheduled, right? So if we do kubectl, actually, I think I have it in history, kubectl scale. Yeah. So let's do kubectl scale deployment, the name of the deployment, and then replicas. I always say go big or go home. Like, let's not scale to 2 or 3 like other demos. Let's do 20, right? And then, okay, that's it. So let's do kubectl get deployment. And right now, so right now we already see that we are going to have 20 instances here. So let's kubectl get pods.
Adrian, maybe you can also show it in the Azure console.
Absolutely. That's a very good idea. So let's go here to container instances, and let's see if we have, look at them. These are the exact same ACI instances, Azure Container instances that are attached to my Kubernetes cluster, right? So you see that the status is pending, but they will transition to running in a few seconds here. Right. So these right now, by default, you're going to get allocated 1 virtual CPU and 1.5 gigabytes of memory, sorry. So, but that can be changed, right? You can change that in the YAML definition of the pod. And here they're all running. Great. So now let's do kubectl get service, and then let's look at what service this Gophers on Azure thing exposes. Okay, this one 40117. Great. Let's do. So let's go to the service itself. And this is it. It only shows the. Sorry, it's a simple app, right? It only shows the Bitcoin price, but it also prints out the host name, and I think this is very important to look at. So just look at the last few characters here while I refresh the page, and you'll see that this is BA24, and then it really likes to stick to some instances, this browser. Okay, so C93, and then it will just keep switching between instances, and then if I'll need like a new in private one here so that it doesn't stick, and we will get a new instance. A2, B0, whatever. So this has a load balancer in front of it, right? So that's really neat, and then it balances between those container instances. And just let's look at looking at the container instances here. gonna put this on the side, and then let's now scale it back, right? Because the point where we needed these has passed, so now we need to scale back. So let's go here and just say 0. Cool, and now we've scaled back to 0, and these will start to immediately go away. Okay, let's look at the deployment. Yeah, the pods are already being killed, like only 4 of them are left, and the deployment is probably now 0. Yeah, so the deployment is now 0. And you see these are going away. By the way, I only got billed for like the minute that I've used these, so this is why this is extremely valuable, because you only get billed for what you're using. So I still have a minute, so I'm going to try to super speed it up with Dapper here. What is Dapper, right? Dapper is an application level thing. So we've talked about infrastructure so far, but now let's switch a little bit to the application level. So Dapper is a distributed application runtime, and it can help you easily and more importantly, very fast to build distributed applications across either the cloud or the edge. And it employs a sidecar architecture. Right, so there's a sidecar alongside your container to help it do things like state management, like mutual TLS authentication between services or pods, and pub/sub architectures as well. And what I'm going to show you today, it can also act as an OAuth proxy for an application that doesn't know authentication at all, maybe a legacy application. The sidecar architecture works very in a simple manner. Like there's an API, there's a Dapper API, and then inside the Dapper API, there's all the logic that you can use, right? Like for state management, publish, subscribe, resource binding. So for example, instead of going to something like Cosmos DB or DynamoDB in Amazon, you can use a binding inside Dapper to connect to that, and your application only now needs to write to a REST API, only needs to do a post, without having to import SDKs to talk to Cosmos and so on, or Redis cache. You can, of course, because of this architecture, you can use any language, right? Because any language can issue an HTTP request. Cool. Yeah, of course. And this is how it looks inside Kubernetes, right? So each pod has a container and then a Dapper sidecar in it. And this is the demo that we're going to look at. So in the general sense, there's a request, and then there's the Dapper middleware sitting in the middle where you can do things like authenticate the user. And then the application is hit, and then the response is being sent back by passing the same exact middleware in the same exact order. In our case, we're going to have a super secret report. That's a legacy application. That's, we've just migrated this, and of course has no authentication because it was running on premise up until now, and it was behind, things that are on premise that do authentication. But now we will take a request, we will authenticate it with Azure AD, it will go to the application, and then we will have the response back, right? So let's see how that's going to look like. CTL get pods. So this is the super secret report. This is my my application. Let's quickly go here to the deploy. And look at how we have configured this, right? So inside Dapper, you have this component resource type, which is, in my case, the middleware. So what it says is that, use the middleware, go to Azure AD, which is what we have here. This is an application defined in Azure AD. And then when you're ready, redirect, after the authentication is done, redirect to my application, which is this one here, which is running on my cluster. And then to make this happen, we have a pipeline configuration that tells Dapper, hey, you know what? You should call the middleware that does the authentication, and the middleware is called OAuth2, which is what I've shown you earlier, right? So this makes basically the bindings between where the request should go. And then we have the the YAML for the for a super secret application, which just says go to port 3000 because that's what the application is listening on, and of course the image. Cool. kubectl describe pod super secret report. I want to describe it because I want you to see that there's Dapper inside of this, and then there's also the application, right? So there's Dapper here, you see the image, and then there's my application. So, it's side by side. It's the same pod, but there are two containers, and the Dapper one is calling into my super secret report. Oh, I'm 3 minutes over. I'm so sorry. Okay, let's quickly switch to an in private instance, and then go to our application, which is protected app.snowboy.org. And this is going to call into the application, which is going to redirect to Dapper for the authentication. Now I'm in Azure AD because that's how it's, this is how it's configured here. I wanted to show you that this is the application here, but that's going to take a few more minutes. So let's skip over that. Let's log in with my Microsoft account because I have permission. I gave myself permissions before this to the application. And now let's just go here, put the password. I have two-factor authentication turned off, but of course you can simply go to the Azure portal, to the Azure AD Blade, and then tick two-factor authentication. And now an application that knows nothing about authentication can have two-factor as well. And that's it. I'm signed in, and now I will get redirected to the application itself. Let's not stay signed in. And the application itself is this one, right, which says Super Secret Earnings Report. And the application will return to me back the headers that it got. And the headers that it got have also the authorization bearer, because this is an access token that we got from Azure AD. And if we quickly expand this, here, you'll see that this is issued by Azure AD for my application. So this is the issuer, which is MicrosoftOnline.com, Azure AD, and you'll see the scope. Yeah, this is my name here, and the scope is login in this case. Cool. So that's pretty much what I wanted to show you. Probably you want to also see that the code of the application is actually one which knows nothing about authentication, right? It just uses the Express framework in Node.js, and then it knows that Dapper is on port 3500, and it will then simply expose an image here, right, and echo back the headers. But you see, there's no Azure AD code that I've put here. And with that, I'll give it back to our presenter, our hoster, sorry, to conclude the session.
Okay, thank you very much, guys. Very interesting. I love that we had a presentation that went into technical and not only skipped along the surface of the problems. It's nice to see that there are many tools built into Azure which we can use out of the box, and yeah, great stuff. So from what I see in our chat, we don't have any questions. So
maybe just kind of let me quickly share something I prepped up. So let me share my screen. We quickly talked about the security story. So this would give you a good overview of pretty much all, I would say, most of the security stuff that's available on the Azure Kubernetes that you get there. As Adrian mentioned, there are a lot of sweeteners out there. You can put like the public IPs on pods, the integration with Azure Key Vault, the integration with the Active Directory, the option to do like pod level security, bring policies as well. So all these things are there as well. And let me kind of quickly show something else. And just to recap, basically run anything, anywhere. So there's like definitely the Windows support of the containers as well. It's there if you want to kind of run it and use it. And the other point that Adrian mentioned is the Azure Arc. And basically through it, you can kind of reach out everywhere. So it's not only the Azure in the cloud, it's Azure Stack. Or if you're kind of running into your own data center or any other cloud, you can kind of benefit from that as well. So definitely check this out. It's pretty well documented. So that's from me, guys. Adrian, any?
I think we went through what we believe they're very important points, and they're maybe the differentiator between Azure and other Kubernetes providers or hosting environments. And of course, there's much more than what we show. We only scratch the surface here. If you're interested in doing that, simply go to the Azure documentation and look for Azure Kubernetes Service. There's so much more in there to learn about and discover. And yeah, I mean, this is a serious service. It's not like we're testing the waters. This is hosting like critical infrastructure inside Microsoft, and also it's hosting parts of the Xbox backend infrastructure. So you know that this is for real, and there is real investment put into Azure Kubernetes Service.
Okay, great. Thank you guys for the very interesting talk. And I hope that our participants will join us tomorrow for another day of exciting information. So yeah, again, thank you very much for your presentation. It was very informative, and I hope we see each other again sometime in the future with other editions of the Cloud Week conference. Thank you.
Thank you, guys.
Thank you. Bye-bye.